One of the greatest and most complex challenges facing modern society today is climate change. But what exactly does climate change mean? To better understand our changing world, let's first explore what gives Earth its warm climate perfectly suited for the evolution of life. The sun, right? It's not that simple. The sun shines down on Earth and warms the planet, just like how a heat lamp holds food warm. The Earth then radiates that energy as heat, warming the atmosphere surrounding it, similar to how a heat radiator warms the air in your home. That's where carbon emissions or greenhouse gases come into the equation. Greenhouse gases are typically carbon-based molecules such as CO2 and methane. These molecules are much larger than other gases in the atmosphere, such as oxygen and nitrogen. Greenhouse gases insulate the atmosphere and reduce the amount of heat escaping into space. This causes the average temperature to rise. Let's look at Earth's recent climate history. This chart compares atmospheric CO2 levels to temperature change. The blue line represents CO2 levels, while the red line represents temperature change, and the x-axis represents time expressed as years before the present. So, all the way to the right of this chart represents today, and all the way to the left represents 400,000 years ago. Three things are apparent when viewing this chart. There are 4 periods of cooling, all followed by periods of warming, each lasting tens of thousands of years. And thirdly, there is an observable relationship between CO2 levels and temperature. But as it turns out, during the transitional period in and out of these small ice ages, CO2 concentration appears to lag behind temperature change by a few hundred years. But wait a minute. If I'm describing a greenhouse gas as a driver of rising temperatures, then shouldn't it be the other way around? Meaning that temperature change responds to CO2 concentration? It would turn out that a different mechanism triggered these earlier climate events. The culprit was natural variations in Earth's orbit called the Milankovitch cycles. These are periodic variations in Earth's orbit that alter the amount of solar radiation reaching parts of the Earth's surface. 3 cycles are particularly important: eccentricity, how elliptical Earth's orbit is; obliquity, the varying axial tilt of Earth; and precession, the change of direction of the axis of rotation, or simply put, Earth wobbles. Now that we know this, what's so alarming about this chart is the Milankovitch cycles are not having a significant impact on warming trends observed over the past century. Milankovitch cycles occur over the millennia and therefore can't be observed, using such small timescales such as decades or even centuries. This means for the first time, greenhouse gases are acting as a primary driver of the warming trend, rather than a feedback to a natural occurrence. So why is all this bad? For starters, as Earth's atmosphere warms, the polar caps melt rapidly, raising sea levels and endangering cities and countries at low elevations like Miami, Cape Verde, New York City, and the Maldives, potentially displacing millions of people by the year 2050. This isn't the first time in Earth's long history that large amounts of carbon have been redistributed in the atmosphere. Thankfully, Earth has a natural process for filtering carbon out of the atmosphere, mostly through oceans and trees. The only thing is, as oceans absorb more and more carbon, it changes the chemical nature of our oceans, making them more acidic and less suitable for life. Our oceans today contain hundreds of miles of dead zone, where life is scarce. Oceans provide a primary source of protein for more than 1 billion people. The presence of carbon does promote tree growth, which is good. The only problem here is that we have been cutting trees down almost as fast as we've been pumping carbon emissions into the air. Consider climate policy this upcoming presidential election.